So apparently I gave, Paul told me that I gave him a hard time choosing which track this talk should go in, because the tracks are divided in types of talks. Apparently this track is for the framework talks. There's another one for the conceptual stuff, and another one for the case studies. But this talk is about some conceptual stuff that I have deducted from working on a framework. So it's sort of all three. And he ended up putting me in this track, in this room, up against Eric Evans in right next door. So I'm happy that there's some people around. I'm going to start with a confession. I have in my not too long career built lots and lots of big balls in mud. So I apologize, especially to those people that still have to maintain those nowadays. I hope for them that they have managed somehow to refactor that into something nicer to work with. And just like Paul, in 2008, I sort of started to dive into this DDD thing. And it was this training where I attended by Eric Evans himself. And it taught me, okay, put some effort in this domain model thing, whatever it is. So I tried to apply that, and well, just imagine we have an application here that has a domain model, and then you map some logic, some services to that model. And if you do this right, you'll notice that the activities that your application has will map pretty nicely to specific concepts in your model. That is, until that one feature request comes in that nobody had foreseen that requires everything. And this is where a very nice application starts to evolve into, well, the mud. And what you then get is pretty normal SQL statements. And this is an example that, this is a query that I haven't been using for a long time. And it was given to me by someone from Denver, actually. And it's only for medical tracking applications. It's not really important stuff anyway, so don't worry. There's nothing bad about this. And he promised me, make sure it's not readable, because there's actual stuff in there, well, whatever. Then the big summary is it contains 22 joins and 6 subqueries. This just tells me the model is wrong for the purpose, right? We're trying to do something that does not fit onto this model. And of course, I'm blaming someone else for writing this query. I have written similar queries. Sorry, I apologize. But how do we get around that, the issue? Of course, a query like that doesn't perform because, well, the model isn't correct, isn't suited for this purpose. But we can work our way around that, right? We can fix all of our mistakes by adding more caches everywhere, right? So what's the point? I mean, this will work, right? Wrong. So I like to think in pictures. And this is a picture I found that describes exactly the same thing as the picture before. This is something that is, in essence, doesn't perform at all. And I'm pretty sure this thing is not built for the purpose that it's being used for at the moment. But then we add lots of caching in, cardboard caches, and spoilers and side skirts and everything. I mean, this has all the characteristics of a high-performance device, right? And if you ask the developer, what did you build? What was your plan? He'll come up with that, right? In other words, we've got a big ball of mud. And you might have noticed, but a big ball of mud is not actually mud, right? It's just a ball of dung, apparently. And in this particular picture, the architect that built it is sitting proudly on top of his creation. I was one of those architects one day. I was really proud of it, and I'm so ashamed that I've created an entire beach full of these big balls of mud. never mind. Anyway, so I don't like making same mistakes twice, so if I encounter problems, I try to somehow fix them. And it started off with an experiment, and I like doing things open source because it allows other people to laugh at my experiment and hopefully also comment back, right? So I started on Google Code at the time, and if you start a project on Google Code or anywhere else, you need a name. Well, the name wasn't Axon Framework at the time. It was a really crappy name. It doesn't matter. And I started experimenting with that. And that started about 2009. I started writing some code. Okay, what is this? DDD CQRS was getting there. And what's this thing? How does this work? And I wrote my first code. And then suddenly, some guy sends me an email. Hey, I'm using your framework in production. I was like, what? What framework? But okay, you know, production, what's production? I mean, you can do fancy stuff and you can do non-fancy stuff and still be in production. So what are you doing with my experiment? Well, it's a medical application, again. And we use your framework to track surgical equipment. I'm like, oh shit. Are you sure? I literally said, are you sure you want to be using this in production for what you're using it for? And they said, well, we've tested it and it works. Okay. And that gave me actually the confidence to start my own projects using my, well, framework by now, I guess. And we moved to GitHub later and then gave it a new name, which was Axon Framework, etc. Then we had a couple of releases. And actually, 2 months ago, we founded Axonic, the company that's now commercially backing the open source Axon Framework. But I've learned a lot of lessons in those times. You can see there's 3 releases in the meantime. And basically, every release means the previous one was completely crap. I'm extremely sorry, but here's one to replace it. And I'm pretty sure there will be more lessons to learn. And one thing I've learned is that a monolith is not a bad thing. Not at all. For one thing, it doesn't smell, usually. Not as bad as that thing. And a monolith is not a big ball of mud. They may turn into big balls of mud and eventually will. But some monoliths take a bit longer than others. And there's some interesting statements if you compare monoliths and microservices. And one I particularly like, which I can relate to, unfortunately from personal experience, is that all the successful microservice stories, at least that Martin Fowler has heard of, and most of them that I have heard of as well, started off with monoliths and then evolved into microservices. Although evolve is maybe not always the best word, they were refactored into microservices because sometimes a monolith was a big ball of mud before they turned into microservices. I've also seen projects where microservices were implemented up front. Like this, there was this huge design of 40, 50, 60 microservices, and a massive amount of teams was bootstrapped just to get started on a microservices environment. And those projects tend to fail. And they take a long time to fail, and they take a lot of money before they fail, which is a particularly bad thing. Failing is all right, but make sure you fail cheap and you fail fast, fail early, learn and move on. And microservices are also pretty difficult. It's hard stuff. There's a lot of aspects to it, and all the talks in this track before mine, they've been talking about this, so I'm not going to repeat all that. You can watch them online if you haven't already seen them. But you have to be at least that tall to be able to use microservices, right? That's the way Martin Fowler describes it. Don't take it too literally, because it would probably mean I can use microservices whenever I want to. and some other people will never be able to. But it's not about the size of anything. It's about, are you really up there yet? Are you able to deal with all the complexities that microservices give you? So how have I seen microservices implemented successfully? And it all starts with the monolith, right? I've been working in greenfield projects a lot, and I enjoy those because you have a blank sheet of paper. There's plenty of room for mistakes, which means that you probably learn from your journey. And you start off with a monolith, still pretty small, manageable, and before it turns into a big ball of mud, you want to turn it into a structured monolith. Make sure that there are very obvious signs of structure in it. And that sounds really easy, and I'll dive into a bit later, I'll dive into how you can achieve that. And as time progresses, you can decide to take certain components out of that monolith and start deploying them separately and treating them like a microservice, if that even exists, right? A single microservice. But the reasons for doing this are usually not functional. They're about team size, or the number of bugs that we see in a particular piece of code is different than the rest because there's a lot of changes maybe, or we need to be able to release that independently. There's dozens, if not more, reasons why it's a good thing to split it into microservices, or to split a component from the rest. And as time progresses, you can do that more and more, right? Now, I have a background in CQRS. I've been applying CQRS a lot, and one thing it helped me realize is that you should not apply it everywhere, and it's not always about CQRS. There's a lot of RS always. There's a lot of responsibility segregation all over the place, but it's not always about the commands and the queries. But it did give me some insight into how to separate models and make sure that they're useful for that specific one purpose that you give them. And if you can't choose a purpose for a model, at least separate on the C and the Q, on the command and the query. So what you get is the separation of models into command models, the models that take commands, make decisions, and emit events based on what they have decided. And on the other side, you'll have projections. They consume those events and build up a projection which is very useful to quickly answer any questions that any client may have about the state of your application. So in theory, the big queries that we saw earlier are replaced by a select star from something, and that's it. That's in theory. And one thing I've learned from this CQRS approach is the importance of location transparency. So to be able to migrate from, let's say, a structured monolith into microservices, to evolve, each of those components in the monolith, or anywhere, wherever they are deployed, they should not be aware of their respective location, their location compared to that of the component they're talking to, right? And that is very easy to say, and it's very difficult to implement, but it's very easy to do wrong, because it starts with correct API design. Most of the APIs we use nowadays are blocking APIs, right? Vaughn talked about that just a couple of minutes ago. And if you look at JDBC, you have a database call, you do a query, you have to sit and wait there until your data has arrived before you can move on with your own application. Why the hell is that? For somehow we assume that the data is just sitting here and we can access it right here, right now. But in most deployments, the database system is deployed on a separate machine. There's a network interface in between. So data is not right here, right now, and yet we're forced to wait for it. That is an example of a non-location transparent domain, API. So how did I do it? And I love messages. And I think messages are a very important element in a model. They should be modeled as if they are part of the model itself, because they describe the interaction with your model. How do you expect the outside world to interact with whatever you're building? And about every presentation I've seen so far today talks about events. I think there are 3 reasons to send a message, and events are only one of them. So an event describes that something has happened, which I think is pretty clear to most of you. Event wasn't described in the blue book, but it was described not much later, a lot. The command and the query, I think, are some of the underestimated types of messages. They're usually implemented by plain HTTP, POST, and/or GET, and they're not explicitly modeled. Right? They just happen to just be there, and some developer just describes them, and here we go. This is how we interact. I like to model them explicitly, because those messages give us the location transparency that we need to be able to decouple components into microservices. So let's look at what these messages mean and how we can use them. Let's start with the obvious one, the event, because I know I can move on pretty quickly. So an event can describe a data change, right? Some state change in the system. Maybe data change is not the correct term here, but it could be a deadline, right? Some wall clock time has passed, and that's important to us. Or anything else, whatever is relevant that happened in your domain, you can emit as a domain event. And events typically have a publish-subscribe pattern, right? They follow this pattern. It's a component that says something happened, throws it out to the world, and doesn't care who or what picks it up or when or in what order, right? It's just, I just want to say it happened, deal with it, I'm moving on with my life. But there's other situations, and sometimes you have components where only one of 2 instances wants to know a specific event occurs. And then things become a bit more tricky, because it's not really publish-subscribe anymore. You're not publishing it to everyone, or at least one of the consumers wants to know, and that means the other one doesn't for now. So one way to deal with that is have exclusive consumers. So have one consumer track a queue, and the other one is blocked from reading from that queue as long as that one consumer is alive. Right? You'll have an active-passive model, which is very easy because you can guarantee some sort of ordering, which we do like. But having idle machines is not the best way to handle all that beautiful hardware that we can get nowadays. So if one machine dies, the other one can take over, fine. If it comes back up, it will just wait for the other one to die again. It gives you high availability, but the throughput doesn't increase a lot. So another way to deal with it is having competing consumers. You can have 2 consumers compete for messages off the same queue. Now this gives you an ordering challenge, right? So maybe the consumers have some ideas about how messages should be ordered, but there's no guarantee here at all, right? These messages are concurrently consumed by 2 instances, and you don't know where they end up. Fortunately, you can have some balance in there. You can use hashing algorithms to decide, okay, we're going to route these events. So if it's 2 events for the same order, for example, we make sure we route those to the same instance. So at least that instance will get those messages in the order they were published, more or less. One thing I want to say is that there's a lot of messaging platforms out there that allow you to do this. They allow you to provide this hashing algorithm, but most of them, and this appalls me to be honest, most of them have the sender decide what the where that message should go, what the actual hashing algorithm is, what the partition is that message belongs to. it's not up to the sender to decide. It's the consumers that have specific expectations on the ordering of messages. So it's the consumers that should decide, I want to have, I don't know, modulo 2 equals 1, then it's mine, which is a very poor and bad hashing algorithm, but it works. So let's move on to commands. So a command is a message you send because you want something done, right? And Vaughan in his talk earlier, he said, well, is it an event, is it a command, who cares, it's just a message. But the sender of the message has a specific expectation, right? So if you send out an event, you expect no response, right? I'm just telling you it happened. Deal with it. If you don't like it, get over it. Because I'm not listening to your response at all, right? If it's a command, you're expecting someone else to do something for you. So you're expecting a side effect to happen, right? You hope that whatever component picks up your command will make sure that the system is in a different state after your command has been processed. Otherwise, there's no point in sending it. And it could be changing the application state itself. It could be sending an email, whatever you want done, right? Usually, you get an OK or not OK reply, so at least you know, OK, it's been executed. In some cases, you can get some data in return. But if you do that, it's about the side effect. It's not about the data, right? So how do you route commands? Usually, they are routed to a single component that can actually deal with that command. And you could do round robin. That's very simple. It's what most load balancers do. So if you use HTTP, you can use a very simple round robin load balancer, and there you go. But we have that same routing problem again. What if we send multiple commands for the same order? If we do round robin, we might be concurrently executing different commands for the same order on different machines. Now, we've designed aggregates to be a group of entities in a consistent state, but here we have an aggregate instance on two machines, and now it's completely inconsistent, because they're both making decisions based on states changes that they haven't seen yet, right? So what we actually want to do is we want to route, again, based on some hashing algorithm. Right? So 2 messages for the same order, send them to the same node. So at least that node can do caching, where caching is actually an optimization and not an attempt to fix mistakes. And it just runs much more efficiently, right? We can assure that we execute this command based on the latest state that we know, which still might be not the actual state because of distributed systems, but it's a lot better than round-robin random messaging. And then there's the last one, and this is one I have to admit I underestimated even in Axon. There's no specific query message. There's commands and events that are really explicit, and I regret that. So in upcoming versions, I'm going to definitely implement this, because queries also have some very interesting patterns. But the query is about, I want to know something. There's information somewhere that I need to either make a decision or just send it to the user, who will then make a decision based on that information. And in a query, it is the response to the query that holds the value of the message, right? The query itself has no value. It's just an indication that you want something. And asking a question should not change the answer. So usually they're side effect free. If you have children, you'll know that that is actually not true, right? Asking a question will definitely change the answer. Daddy, can I? Daddy, can I? Daddy, can I? No, 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 yes. But IT, computer systems are usually better at that. Maybe they would make perfect parents because they'll say no anytime because the state is no, right? So maybe I should have my kids talk to the computer instead. Now I'm learning something from this. That's cool. And I've seen different messaging patterns in practice for these queries, and that's why I regret not having them implemented explicitly. Most most queries are single destination. Now, they're an HTTP call that whatever console instance gave us the address for, we send an HTTP call to that address and we say, give me the price of this product. And it gives you a price and we assume that's true. And that will probably work. But there's some interesting things you can do with scatter-gather types of queries. So let's look at point-to-point. You have a component that sends a query to the component on the right, and the component on the right gives you the price, right? Which is fine, it works. And this is really nice if you have a single authoritative answer to your question, right? There's just one answer that's correct. But in most applications, that's not really the case. So in the supermarket I go to, an article doesn't have just a price. It has a price for the regular customers, and it has for whoever has the bonus card. And you can get one for free, but of course you have to give up your privacy for it. But at least you get lower prices. So they have an if you have a bonus card, then you get a lower price. So there is no single authoritative answer to the question, what is the price of this article? Because it depends. Who are you? Right? So in this case, the actual result is, well, first of all, you ask the question, you get all these results, and you choose the lowest price that you get. And if the component down below decides that you're not a bonus card holder, it will just not answer the question, because I don't have an answer to that question for this specific context. And what you can then do is decide, well, you know, it's good weather now, so probably people are not going to buy winter stuff. This is, of course, if a component goes down, then we'll have the regular price, and this is really bad for the bonus card holders because they don't get a discount, but at least the system keeps running. Right? But what if it is summer, and you decide, all that winter stuff, we lower the price for it. You can deploy a new component that starts answering these questions, and if it decides that, hey, the parameters for this product are correct, we're going to send 99 as a response, then suddenly prices drop, simply because you've deployed a new component. So you can change the behavior of your entire system by just adding a new component to it. You don't have to change anything else, which is both very comfortable and very dangerous if you deploy something in error. If there's a mistake in that if statement, everything becomes really cheap. And it happens in practice quite a lot. And of course, when winter kicks in, you're going to undeploy that application to make sure that the discount isn't valid anymore. And these patterns are all very nice, and we can apply them. But we all know that at scale, different rules apply. Right? Things that work in a very small, safe environment don't work in the hell called production. Because how do you route all these events and other messages to all these components, right? How do you make sure that when you publish an event, that every component will be able to read that? Well, the easy answer is it doesn't. It doesn't work at scale like this. You can't take this concept and just build a microservices environment. And it's not even a technical issue, because we can get messages to thousands of other components if we want to. But what we get is a mess in terms of language coupling. So this is not, the ball in the middle is not the physical, let's say, Kafka or whatever messaging pipe that you have. This expresses language dependencies. So now, if we have a shipping module down here that wants to know when an order is placed, that's the terminology they apparently use in shipping. Right? An order is placed, then we prepare the shipment. But the order item doesn't talk about order placed. It talks about an order is created, an item is added, another item is added, the shipping address was added, an item was removed, an item was added, an item was added, and then we had the billing address, and then it was confirmed. Wow. So now that shipping module has to do all the math of adding and removing items just in case an order confirmed event may or may not arrive. And what about it doesn't arrive for 7 days? Does that mean the order was cancelled or ignored? Can we ignore it? Can we throw it away? So you have there's a huge dependency now between the shipping module and the order module, just in terms of language. And there's a lot of logic that you need to duplicate there as well to make sure that we can calculate when an order is placed. So how do we make sense of this? And there's too much text on this slide, so I recommend you don't read it. But the concept of a bounded context will help here. And there's a lot of debate around the relationship between DDD and DDD and microservices in the context of the bounded context. How does that relate? And I see microservices, it may be one, it may be many. They sit in a specific bounded context, right? They speak a specific language. And within services that are within the same context, they can safely share events because they speak the same language. They don't speak order placed, no, they speak order created, items added, orders confirmed, etc. And in between these contexts, you want to be more conscious about what types of events you want to, or messages, to be a bit broader, you want to share, right? You want to speak somewhat a higher level of abstraction style language between them. So as a shipping module, I still want to know when an order is placed, because that is what I understand. I don't care about all the intermediate steps. They carry absolutely no value, right? And this order placed event probably contains the items that were bought in that order, as well as the address that they need to be shipped to. And that component still speaks the language of order created, etc., etc. And now we can have some, well, you could call it anti-corruption layer or a translation component, whatever, that knows, oh, placed. That is when an order is created, a number of items have been added, and then the order was confirmed. Now we can construct an order placed that we can send out in the world and other components can safely use. Right? So we get less coupling. Now, in practice, I've noticed that the messaging stuff is pretty hard to get right. And I've been working as a consultant for a long time before starting Axon, where I still work as a consultant every now and then. So I have seen a lot of projects where they have or haven't used Axon to implement their monolith, their structured monoliths, and now they decide, okay, let's start tearing them apart, but now we have to reinvent how we do messaging. So all these patterns, events are pretty simple, but what about the commands? How do we consistently route them to the right machines? And everybody is solving the same problems in different ways, because we tend to not share a lot of information about how we solve specific problems. Fortunately, there's conferences like this where people do, but this is just 2 days in a year of 360, right? So that's the mission that Axonic has taken on to provide a number of APIs and implementations necessary for these event-driven microservices, and maybe we should call them message-driven microservices, because it's not really only about event. And our goal is to have you focus on the business logic, because that is what drives the business. It's not that underlying technology. That's just in support of getting messages from A to B, or making sure that data is properly stored as we move along. So a number of takeaways from this talk. Microservices are a journey, right? It's not something you want to do from day one. Well, if you want to fail in a miserable way and make some money on the way, if you're a consultant, then that's probably fine. I know some companies that have grown pretty big with that business model. And DDD and CQRS, for me specifically CQRS, they help define these logical boundaries between services and contexts, etc. Most importantly, location transparency is key if you want to build a structured monolith. Right? If you don't have location transparency, your monolith will stay what it is, a monolith. You will never take it apart, right? Or at least you have to take a decent amount of effort to try to take it apart. Explicit messaging definitely helps in making components location transparent, and make sure that these messages are part of the model. I guess that leaves plenty of time for questions, right?
If you do have a question, just wait for the microphone to start. Hi, I have a question about the query. Query as a message. So I'm presuming that you meant an asynchronous query. So am I imagining it right that one microservice is querying another microservice through an asynchronous mode? And that is, I'm having a hard time wrapping my mind around that one.
Okay.
Events and commands are one directional, so that's fine. But this is more of a request and response. And how do you pull that off? Curious to know.
Yeah, so in queries, first of all, I don't like thinking of a query as one component asking another one for information, right? I like to see a query as, oh guys, I've got a question. What is the price of this article? And whoever knows shouts, right? Because I don't know, as a component, who has the answer. And there may be multiple components having the answer. So I'm not going, do you know what the price of this article is? Do you know what the price? Do you know what the price? That's what they do in a supermarket sometimes. Right? There's two models there. They like, okay, call this number. And they say, yeah, what's the price of the grapefruit? And the other one is, ding dong, what's the price of the grapefruit? Yeah. And then all people start shouting, I saw it at $2.99. Okay, thanks. So that's one. And the other one is, yes, it is asynchronous because you don't know where the component that has the answer lives, right? So why should you have an API that forces you to wait for it? Maybe you have two questions to ask, and you just want to get the questions out and then wait for a specific amount of time and decide, okay, if I don't get the answer within 1 second, which is extremely long, but if I don't get the answer in a second, I'm going to assume nobody knows the answer, or I'm just going to give the article to the customer and take it for free. So it allows more models. Yeah. Can you get the microphone?
Then which is the system of record? If you do not know that who has the right answer, then are you moving away from the concept of system of truth or system of record?
No, I'm not. I'm just saying that whoever asks the question is not responsible to know where the authoritative answer is.
Okay, fair. Yeah. Thanks.
I have a question here in the middle.
So your last bullet there, treat messages as part of the model, that's really interesting, but I'm trying to understand practically. In your example earlier, you talked about one bounded context had order placed, so as a message would be emitted as this concept of it's placed, and the other bounded context had the concept of order created. So if that message is part of the model, is it two different kinds of messages, really? Like in the one context, it's the message with this idea of placed. In the other context, it's the idea of created. How does that work?
That's exactly it, yeah. So what I see when there's modeling activity going on, there's a lot of entities being drawn and a lot of aggregates. And if you do event storming, there's a lot of events as well, right? But why put events up there and not the commands and the queries? Why not think about what the queries should look like, or what the commands should look like, what information they should carry? Just like events, right? You talk about events and when do they happen? What do they mean exactly? And so they are treated as part of the model in most cases nowadays. Why not the other messages? So what I see in practice is that the events are being thought of, and then the commands, it's like, okay, that's a developer on his workstation that decides, oh shit, we needed a command here. Let's put this in. And that's what I mean. Design that. Take that as part of your design. Any other questions? Yeah.
I think where I was still trying to struggle to understand is this concept of location transparency. Can you repeat that, what that is?
So the idea of location transparency is that a component is not aware nor interested in the location of any other component it interacts with. So that other component may be living in the same JVM, and we don't have to use inter-process communication. We just an event bus inside the JVM is just a for loop, right? Take all the registrations and give them the event in a for loop. That's it. But for the sender, it shouldn't care whether that's the case or whether there's a Kafka or a RabbitMQ involved, right? So that's the location transparency. It doesn't matter where the event comes from or where it's going. From an API perspective, I just want to say, here it is, and it's gone. Right? That's easy for events because it's pretty clear that they're fire and forget style messages. For commands, you have an OK response, right? But in your API, make sure that you don't treat the OK, you don't force anyone sending a command to wait for the OK. Just give them some sort of a promise or a future or whatever the mechanism is called in your language, and say, this is an object where you can, whenever you're ready, you can check this and see what the result of the operation was. Because at some point in time, you're probably going to get a response, maybe. And that's important, to have the APIs designed that way. Because that allows the client to decide, do I want to wait for the response, or do I want to move on with other stuff? In the best case, at least give up the thread that was sending the command to do something else, to take up a new request. And whenever the response comes in, we'll use whatever thread is available to handle that response. It gives you much more flexibility, and in the end, also improve performance massively. But it is, I mean, as Vaughn said, we are addicted to that force to wait. You know? If we send a command and it's going to happen right here, right now anyway, so let's have the response there right now. And it's just an addiction we have. Well, we have to get out of that, get away of that addiction, and start treating async as a normal thing. Right? And that's what location transparency is mainly about.
Just so again, first part for events, you said it's location agnostic. I don't care, or I shouldn't know where it's coming. That's the transparency where that sort of confused me. But really, you're saying know the future, or give them that object that eventually would show up. Is that what you're becoming transparent about? Just maybe the naming.
Building the API with the future is a way to implement a location transparent API. There's probably other ways. Having no return value at all is also a way. That's the fire and forget, right? That one is easy. Because how do you guarantee an event is really gone? How can you guarantee? It's a question I often get. I send an event. How can I guarantee that the other component is handling it? Well, you can guarantee that some way or another, but you definitely don't want the sending component to implement that guarantee. You want whatever infrastructure in between to be able to guarantee that. It's not the sender's responsibility. That's part of the location transparency. Unfortunately, it's not a term that I came up with myself, or maybe fortunately, it's not a term I came up with myself. So that's key. Any other question? In that case, thank you very much for attending.